Hello all, my name is Krish Naik and welcome to my YouTube channel. So guys, recently I had conducted a 3 hours live workshop to explain about GraphDB with Langchain. In this entire session, we discussed about GraphDB, we discussed about knowledge graph. We also discussed like if you have a specific data, how you can actually convert that into a knowledge graph and store it in some kind of GraphDB such as Neo4j or RDB. So that part has also been completely explained. And finally, we did cover end-to-end RAG projects specifically with the help of GraphDB and Langchain. Now, this particular session was a paid session. I took a minor, like a small token of money, like 50 rupees minimum for the entire session. The reason was very simple because I was conducting this entire session in Zoom. Okay. And there were some kind people also who donated more so that everybody can attend this specific session. By seeing this kind of kindness, further going ahead, if I am probably taking up this session, this kind of live session, I will make it available or free for everyone, at least 1,000 people, because in Zoom, if I'm taking that 1,000 people subscription, like 1,000 people webinar, it costs you somewhere around 50,000 rupees, per month. But I'm okay to bear that specific expenses. And obviously you have also done some kind of donation that actually helped me out for taking this specific session. But again, I will be depending on some amount of donation from your side. If you can, please do definitely do that. But going forward, any live sessions that I'm actually taking, and I'm planning every weekend on Saturday, I may take some kind of live session. The next live session that I'm planning is specifically for LangGraph, right? How do you can actually work with LangGraph, how you can create multiple AI agents, right? So let's see how that will probably go ahead. But I will be sharing that entire information with you, how you can register it and all. Once that particular session is planned, I will be sharing it in my YouTube channel itself. But in this session, please go ahead and check out this entire session on GraphDB with Langchain. It is an amazing session. 2.5 hours I've actually taken this entire session and explained each and every thing about GraphDB so that you can also start it. The main aim of this kind of live session is to take newer topics that are specifically coming in the field of generative AI and explaining you in a separate live session itself, where I also get a chance to interact with you all, right? So going forward, any kind of session that I'm actually going to keep, I will keep the limit to 1,000 people. Today in this live session, we had around 200 people and it was fun. I was able to interact with many people over there. I was able to ask any questions and I was also able to understand like what you all actually want. And since generative AI is evolving so much, new things are specifically coming up. So this kind of sessions will definitely be helpful for you. So yes, go ahead. And all the people were very kind. They said that, hey, Krish, go ahead and upload it in the YouTube. Upload it for everyone out there so that it will be beneficial for you. Thank you for everyone for supporting this, taking this particular initiative. I will not be able to earn much over here, but I will be putting my own money, my own efforts over here. But at the end of the day, this will be really beneficial for all of you out there. So yes, this was it. Go ahead and enjoy this particular session and let me know in the comment section whether I should be continuing this kind of sessions or not for you all. So yes, let's go ahead and enjoy this session. Thank you. So first of all, let's go through the agenda of this session. Okay. Agenda. So in this agenda, first of all, we will try to understand about knowledge graphs. Okay. The second thing that we are going to discuss about is Neo4j graph database. The third topic that we are going to talk about is Cypher query language. Cypher query language. The fourth topic that we are going to discuss about is with respect to GraphDB with Langchain. So all these topics we are specifically going to discuss in this session. It will be in-depth intuition. We'll try to understand it, much more practical implementation. Everything we'll try to cover as we go ahead. Okay. Now, first of all, let's quickly see this. Okay. First of all, what I'm actually going to do is that we will try to understand What exactly is this knowledge graph? So the first question that comes in our mind is, what exactly is knowledge graph? See, knowledge graph, if I really want to go ahead with a definition, it is a semantic network. And this network, it is a network of real world entities, real world entities. If I probably take as an example, okay, it can be any events, it can be situations, okay, it can be concepts, right? It can be names, it can be different terms that we will be using, as we go ahead, okay. And whenever we talk about this event, situation, or concept, it illustrates the relationship between them, okay. It illustrates the relationship between them, okay. Let's take one example, because anyhow, if I go ahead and write any number of definition, uh, at the end of the day, it is always difficult to understand the definition with complex words. So it is always good that we have multiple examples, okay. Let's take one amazing example, okay. Recently, as you all know, India has won the T20 World Cup. Who was the captain for T20 World Cup? Rohit Sharma, right? So I will just go ahead and write Rohit Sharma is the captain of Indian cricket team. So let's say this is my sentence that I have. Okay. My other sentence can be, let's say, who was the wicket keeper of India? So let's say I'll go ahead and write Rishabh Pant is the keeper of Indian cricket team. Of Indian cricket team. Okay. When I have these two simple sentences, okay, according to the knowledge graph. So if I probably take a knowledge graph, this knowledge graph will take this entire sentence and it will divide this entire sentence into three main components. Okay. So here we are going to specifically divide this into three main components. Okay. This entire knowledge graph. Okay. The first component is something called as nodes. What is exactly nodes? Nodes are nothing but any objects, places, or person. It can be a node. Okay. Second one is edges. If I take edges, so I can go ahead and define an edge defines the relationship between the nodes. Between the nodes. Okay. And the third thing that we specifically talk about is nothing but labels. Okay. Now, what exactly is this labels? We'll just talk about it. Okay. Let's say the two sentences that we have, one of the node is Rohit Sharma. Okay. See over here. Rohit Sharma is the captain of Indian cricket team. So one node I can probably create this as Rohit Sharma. The second node that I may have is something like Indian cricket team. So Indian cricket team. And one more name was specifically used, that is Rishabh Pant, right? So I will just go ahead and create my third node. Okay. Now, as I said, an object, places, or person. Okay. So here, one of the node is Indian cricket team. Then here you have Rohit Sharma. Then here you have Rishabh Pant, right? From the sentence, we know that Rohit Sharma is the captain of Indian cricket team. So when we say Rohit Sharma is the captain of Indian cricket team, so here the kind of relationship that we have is captain, right? Similarly, we have said that Rishabh Pant is the keeper, wicket keeper. So if I go ahead and see the relationship between Rishabh Pant and Indian cricket team, it is basically written as wicket keeper, right? Now, don't you think if I have this two specific relationship, can we derive the third relationship over here? Something will be there, right? Some relationship will be there with respect to Rohit Sharma and Rishabh Pant. It is very much easy to understand. Let's say one of the relationship that we specifically derive, these both are teammates. Teammates. Okay. Now, just with this two sentence, we are able to take out so much of information. But just imagine in this internet world, there's so much of text, right? Regarding Rohit Sharma, regarding Rishabh Pant, regarding Indian cricket team, regarding other players. Now, what will happen if we take this entire chunk of text? We will be able to create this amazing graph, right? So there will be one more node over here. This node will be getting connected to this. This node may get connected to this. There may be one more node. This may be connected to this. This may be connected to this. Let's say if I take one more example like Virat Kohli. In some of the newspaper says, hey, Virat Kohli is the brother of Rohit Sharma, right? Not motherly brother, but yes, cricket brothers, right? Because they support each other. Suddenly, Hardik Pandya will come up, right? So Hardik Pandya, because of IPL. So here I have this Hardik Pandya. Hardik Pandya and Rohit Sharma. Are they friends because of Mumbai IPL? Right? Before Mumbai IPL or during Mumbai IPL, people will take out some other information. Hardik Pandya and Rohit Sharma are having 36 ka akda. Okay, they'll say something like that. But after winning T20 World Cup, they have also now become friends. Yes? Everybody is able to understand this? Yeah? Just imagine the entire world is having so much of internet data. And how this entire nodes is basically created. Do you know in NLP, we have something called as, if you probably have used scikit-learn and all, you have this, I think, to capture the entity, right? You are able to capture it. If you give a sentence, you'll be able to take out the names, right? You'll be able to take out the places names just by using scikit-learn. And that is nothing but your NER, right? What is the full form of NER? Come on, anyone? What is the full form of NER? Tell me. Yeah, it is a part of speech, right? So yes, name entity relationship. Name entity relationship. Name entity relationship. Okay. Sorry, name entity recognition. Okay, sorry. You can also say it as a relationship, no worries, but name entity recognition. Yeah. Now, through this name entity recognition, you'll be able to identify name, you'll be able to identify places, you'll be able to identify anything as such, right? Now, combining all this specific information, and right now, even in Google search, they use this entire graph knowledge extensively. Because just imagine if I'm searching for Hardik Pandya, don't you think I'll be getting suggestions of Virat Kohli, Rohit Sharma, Indian cricket team, Rishabh Pant? I can get, right? If I just search for Hardik Pandya, I will be able to get this all kind of suggestion. Agree? Yeah. If I am searching in YouTube channel, let's say if I go ahead and search in YT about Rohit Sharma, okay, then I may get some videos of Rohit Sharma. Then probably it may suggest me some other matches of Indian cricket team, right? Then based on this, I may also get advertisements in my YouTube videos, right? It may be related to sports apparel. It may be related to shoes. Yeah. I hope everybody is able to understand this. Yeah. Yes, yes, yes or no? Please tell me. Yeah. Perfect. 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 Now, Let's talk more about this knowledge graph. Okay. And as I said, that knowledge graph is right now being extensively used, extensively used. Let me take a wonderful example. So I will go over here and I will just go ahead and write my name. Let's go ahead and write my name. Okay. So here you can see Krish Naik. Now see, in Udemy, I'm selling. I'm going with the courses now. Udemy is also sponsoring. They are putting ads with my name only directly. I think people may have searched for my name. Okay, but others. Do you see this information that you see over here? It shows, hey, Krish Naik on Google, YouTuber, overview, videos, interview, books. Right? All this information are specifically here. GitHub, LinkedIn. You know, I've just searched for my name and I'm able to get all this entire information, right? Now, if I go down, do you see over here? People also search for all these people. Yeah. Now, why do you think these suggestions are coming? I hope everybody knows about Joshua Stammer, right? He also teaches amazingly in YouTube, right? Specifically theoretical intuitions, right? See over here, Lex Fredman, Corey Schaffer, these all are people who are there in the same field as mine, right? I'm in the YouTube field. I have been uploading videos related to data science. And now here you can see that they're also searching this all information. Let's take one more simple example. I know I'm not that famous. Let's go and search about Einstein. So if I go ahead and search about Albert Einstein, do you see this information? Albert Einstein information is basically coming up. Overview, education, videos. Now here you can see Einstein was born on 14th March 1879 in Germany, right? And died on 18th April 1955. This information is definitely there. Now, if you go down, see this. People also searched for these all people, Isaac Newton, J. Robert, Stephen Hawking's. Why? Because these all are scientists. They did some amazing breakthrough research, right? They came up with something very amazing. And the best thing about it is that the suggestion that you are actually getting right, some of the suggestion will be from the same period where these people were born, right? Yeah, we know that Stephen Hawking was not born over here, but Stephen Hawking may be related to Albert Einstein through some research, similar kind of research that they are specifically doing. Now, I hope you are able to understand, because see, if you also go ahead and search for any YouTube videos, any suggestions that you are able to get, any auto suggestions that you are able to get, any advertisement that you are able to get, right now it is extensively using graph knowledge. Okay, knowledge graph specifically. I hope it is clear enough. And I hope you are able to understand these things, right? Okay, just give me a quick confirmation once you are able to understand things. Okay. Now, let's go to one more kind of search, which is called as hybrid search. Now, see why this is important. And the main topic, specifically when I say with RAG application. Okay, with RAG application. What is RAG? Okay, retrieval augmented generation, right? So here, whenever we create a RAG application, what do we do specifically? Okay. Don't worry, I will talk about labels and everything as such. Okay. Now, see, initially, whenever we create a RAG application, initially we may have some kind of documents. Okay. We have some kind of documents. Then the next step, what we do after ingesting the documents, we divide these documents into chunks. So this is my chunk one, this is my chunk two. Why do we divide this into chunks? Why don't we take this entire document like this? Why? Because every LLM model has some limitation with respect to the context size, right? Some context size. Right now, recently, Meta has launched something called as Llama 3.1. This is an open source model. It has 128K context size, right? Now, 128K context size is very huge, but for most of the models that are available right now, specifically with paid and open source, they have smaller context size, right? So what we do is that we divide this document into chunks. After we divide this document into chunks, I'm considering this as my NLP documents. Okay. NLP documents basically means text is specifically there. Now, when this chunk is there, I will take this chunk and what we do in the next step, we convert this into embedding vectors. Yeah. What is embedding vectors? Embedding vectors are nothing but we convert all our text into some numbers. These numbers are also called as vectors. What is the purpose of these vectors? The reason we convert this into vectors, because these vectors will actually help us to apply some simple algorithms like cosine similarity, right? Some of the algorithms like cosine similarity. Through this, we will be able to do what? Similarity search. Similarity search basically means if I ask any question with respect to this particular documents, I should be able to retrieve that particular value, right? So this is my embedding vectors. And for embedding vectors, there are different embedding techniques that are there, right? Word2vec is there. In Hugging Face now, open source techniques are specifically there. In deep learning, we used to use embedding layers. At the end of the day, it will understand the context of the entire text and then it will convert that into vectors. It will convert in such a way that all the similar words will be very much near to each other. Let's say if I have a word like king, king may be present over here, queen may be present over here, man may be present over here, right? So all the similar words will be together. All the opposite words will be far away from each other, right? And once we convert that into the embedding vectors, what do we do in the next step? Tell me. What do we do in the next step? We try to save this in some vector database. Tell me some of the vector database that you have used. Tell me some of the vector database that you have used. Okay. One is Pinecone. You may have used Pinecone. Have you used Cassandra or AstraDB? AstraDB. One of the most common one is Fias, right? It was developed by Facebook, right? If you see one more is something called as Chroma, right? Now, in most of this vector database, once we store this embedding vectors over there, then what will happen? Whenever user queries, okay, queries, whenever a user queries for any information, over here with respect to this particular queries, two types of queries will basically happen. Okay. One is keyword search. One is keyword search. And the other one is something called as dense vector search. Have you heard about this term? One is keyword search and one is dense vector search. In some of the databases, we go ahead with keyword search. In some of the vector databases, we go ahead with dense vector search. Like if I probably consider Fias and Chroma or AstraDB Pinecone, it supports dense vector search. Some of the databases only support keyword search, okay? And some of the databases supports both this vector search. The databases which supports both this vector search is basically called as hybrid search. Hybrid search. Okay. Whenever we say keyword search, okay, this dense vector search is also called as semantic search. Why it is called as semantic search? Because based on the similarity, this dense vector basically happens. See, king vector will be something same to the queen vector, or king vector may be something similar to the man vector, right? So this vector search is basically done based on the similarity, right? Similarity score that we are specifically getting. Okay. Now let me just talk more about this keyword search and all. So first one, we will go ahead and talk about keyword search. Now what exactly is keyword search? See, some of the techniques that you know about, right? Like bag of words, TF-IDF. Have you heard about this techniques in NLP? Right? This specifically uses keyword search. Why? Because more focus is given on the words over here. More focus is given on a specific keyword. Right? Let's say I have a sentence. The lion roars. If I probably consider bag of word, and let's say if I have this specific word, if I have the will become 1, remaining all will become 0. If I have lion, then this will become 1 and remaining all will become 0. So here we are specifically focusing on the keywords. right? And based on this keyword search, we are just making sure that we give more value to that specific word. And since we have more number of zeros and ones, so this basically becomes a sparse matrix. What does it become? A sparse matrix. What is the problem with sparse matrix? Maximum number of ones and maximum number of zeros. There will be only zeros and ones. The sparse matrix leads to overfitting also if we train this specific model. And there are a lot of problems with respect to sparse matrix. Okay. So when we are doing keyword search using sparse matrix, we are just focusing on one single word. Now, what exactly is the issue with sparse matrix? It leads to overfitting, guys. You can check my YouTube videos in my YouTube channel regarding bag of words and all. There I have actually explained. Okay. It is more about a technicality term. How does it make sure that overfits? Because the models are having zeros and ones, and just at one place there will be one, right? It tends to overfit with respect to our training data set. Okay. The second important search is basically called as semantic search. And this is also basically the dense vector search. Dense vector search. Now, in dense vector search, we try to find out our output based on the similarity score, right? Similarity score. Let's say if I have two vectors, we'll try to find out how, let's say if I'm searching for any vector, right? When we say similarity score, that basically means I have a query vector. Let's say I'm querying it with respect to a vector. Let's say if I'm querying a vector, let's say I'm searching for king. This king will get converted to some vectors over here. And when this hits my vector DB, it is basically going to see which similar vectors is available in this vector DB. Right? And then we get the specific response. Okay? Then we get a specific response. Now, to make the performance much more better, right? To make the performance much more better, the third technique that we specifically use is something called as hybrid search. Okay? Hybrid search. Shirang says how king is converted to a vector. Shirang, you need to have a basic knowledge of NLP with machine learning, because understand without this, you will not be able to understand. So that is the reason I have told you that prerequisite is that you need to know the basic things before, like NLP with machine learning. What are the different vector techniques? What is vector embedding? What is word to vec? All these things, right? So what is context window in LLM? Okay. Let's say, guys, you are giving a request. I give a request of 30-page PDF. Okay, 30-page PDF. Do you think we can send this entire PDF to our LLM to get the response back? Do you think? No, right? It will not be possible, because this LLM may have some restriction with respect to maximum number of context that it can accommodate, right? Some minimum, some maximum token limit will be there. Let's say over here, this 30-page PDF is just having 100K tokens. But if this LLM model supports only 50K tokens, I'm just taking as an example, then do you think we can accommodate this 100K tokens over here? No, right? Ramesh, that 128K tokens were for Llama 3.1. Okay. So if you have Llama 3.1, then you can accommodate this entire thing. Okay. Now, hybrid search, the best thing about hybrid search is that it uses two techniques. One is keyword search, and one is semantic search. Now, don't you think, guys, if I use both these techniques, my speed, sorry, not my speed, my accuracy of getting the response will be better? Yeah. Yes or no? My accuracy to get the response on the vector DB will be much more better when compared to only semantic or keyword. Yeah. Now I will just add one more point. What if I add to this knowledge graph? Now tell me, how will my search be? Will it become better or will it become bad? It will become awesome, right? It'll just become much more better. So here, with respect to the GraphDB, we're just not focusing on keyword search. We're not just focusing on semantic search, but we are focusing on knowledge graph. So based on this knowledge graph, the keyword search and semantic search will also get integrated. And at the end of the day, our RAG application will be able to give you much more better response. Yeah. And the best thing is that knowledge graph can be applied for any kind of text. You don't need to have any kind of input or output. You just give it a text and you give the text of the entire book or whatever text you have in the entire world. Okay. That I will show you as an example. Okay. So I hope you have understood the importance of knowledge graph. I hope you have understood the importance of uh, hybrid search along with knowledge graph, right? So this is the power, right? And you will be seeing as we go ahead with multiple examples. Okay. Now, let's go ahead and talk about one very important topic. Okay. So I hope you got an idea with respect to all the things. Now we need to understand what is the difference between RDBMS versus graph database. Without this, you will not be able to understand each and everything. Okay. Okay. Before this, what I will do, everybody just go to this Neo4j Aura DB. So search for Neo4j Aura DB. Okay. Everyone, please go ahead and search for this. Quickly search for this Neo4j Aura DB. Prasajit says how LLM context window is decided. That depends on the LLM, the company that they are training, right? The LLM model, how the company has basically trained. Okay, everybody went to this particular URL, Neo4j, yeah, Aura DB. Yeah. Now, we will go ahead and create one instance of a graph database. The reason why I'm taking this step because it will take some amount of time to probably start this instance and you can start it for free. So just go ahead and click on start free. Okay. Did it ask you for sign in? Please go ahead and sign it with your Google account. Please go ahead and sign it with your Google account. Okay. And just give me a confirmation once you sign in with your Google account. Okay. Go ahead and sign in. Okay. Now, the next step over here will be that you have to just go ahead and click on new instance. Okay. Once you click on new instance, do you see these three options? One is free, professional, and enterprise. Free, professional, and enterprise. Please go ahead with the free one and click on try for free. Okay. Try for free. Or should I do along with you? So let me do one thing. Let me delete this. Okay. And then we will start from starting. I have already created one instance 01. I will go ahead and destroy it. Okay. Till this gets destroyed, then I will go ahead and create my new instance. Okay. See, I had created some amazing graph database over here, right? But it's okay. We will start from starting. Okay. Anyhow, this is free. I'm not muted, Vamshi. I hope everybody is able to hear me. Okay. So let's delete this. Now here, everybody start from this. Okay. So first of all, we'll go ahead and click on new instance. Then you have this free plan. Let's go ahead and try it for free. Do you see this generate password and all? Please click on download and continue. So once you click on download and continue, this will be your entire password that is saved. Okay. So we will be using this password for our coding, right? You'll be having information like Neo4j URI, Neo4j username, Neo4j password. Okay. So now the instance is basically getting created. Okay. So let the instance get created. Then again, we'll come back over here. This will take some amount of time to get created. Okay. Now let's go ahead and compare the differences between RDBMS versus graph database. What is RDBMS? What is RDBMS? It is nothing but relational DBMS. Okay. And in relational DBMS, if I probably take an example, you have MySQL, You have SQL Server, right? Now you need to understand the differences between RDBMS and Graph Database. So first of all, we will go ahead and write it down over here, RDBMS and Graph Databases. Okay. The first difference is that in RDBMS, do we create tables? Yeah. Do we create tables? So in RDBMS, we create table. Similarly, in Graph Database, we create graph. Okay. The second thing is that in RDBMS, we insert records, which we also say it as rows. Okay. In Graph Database, we insert nodes. How nodes is basically determined by a circular node like this. Okay. Then the third, in RDBMS, we have columns and data. Yeah. In Graph Database, we have something called as properties and values. What do we have? We have properties and values. In RDBMS, we have something called as constraints. What are these constraints? Do you know what are constraints in RDBMS? I will share each and everything. Don't worry, guys. We have something called as primary, foreign, candidate key. So, right, we have all these constraints. Yeah. And over here, we have something called as relationship. Relationship basically means, let's say I have like this, Rohit Sharma is the captain of Indian cricket team. So this captain is nothing but it is the relationship. Okay. Everybody clear? Yes. Yep. Now, what is so amazing about this Neo4j? Okay. So let's discuss about Neo4j and we'll probably cover some of the advantages. See, there are a lot of open source graph database also, but we are using Neo4j because it provides a lot of features. The first feature is that it provides you real-time insights. Real-time insights. Okay. The second thing is that you will be able to get it, like you'll be able to perform an easy retrieval with respect to any query. Any query basically means here we will write as cipher query. Okay. Okay. One more point that I forgot to write over here in RDBMS. If I probably consider MySQL or SQL Server, we write a SQL query. Yes. What is SQL? Structured query language. Here we write something called as cipher query language. Cipher query language. Okay, everyone. So, as I said, for easy retrieval, we specifically write cipher query. What exactly is this cipher query language? And this also, Neo4j also supports cipher query language. So here we are going to write cipher query language. And with respect to the cipher query language, it is a declarative query language to represent the graph visually. Okay. And one more thing about this cipher query language is that the most important thing. See, guys, what is the most tougher thing that you face in MySQL? Tell me. Don't you think nested queries, joins, right? This is probably the most toughest things that you have to probably write, right? In a query, right? Here, you don't have joins. You don't have to probably write joins or no nested queries also, right? And because of this graphic representation, no, I will show you. Even if you're not good at, I know today many people are starting cipher query language, you will be able to understand, hey, it is very much simple, and just by using Google and probably some common sense, you will be able to understand how things work. Okay. And that is what I'm going to explain you in this video. Okay. Everybody clear in this? So let me just drink some water and then I'll continue. So how's the session, everyone? Yeah. Don't you feel that the sessions will be amazing if I keep on continuing every weekend? Every weekend, 2 to 3 hours, you'll have fun. Yeah. Yeah. Yes, every weekend will be great, sir. Yeah, Saturday I will plan for 2 hours because every day I'm putting a lot of effort for somewhere around 3 to 4 hours just recording videos, updating all my Udemy's videos, right? Because these all are updated like all in 2024, whatever new things are basically coming. Yeah. And yeah, revision will also happen specifically. Like, and you can also let me know, right, which all sessions you require, right? You can comment down, you can probably suggest me and all. Manorama, I don't have any coupon code for this month. After 4 days, I will share you. Okay, I will share all the codes. So please make sure that you be in that community group. Install the Tag Mango app so that I will be able to provide you. And don't worry, every time whenever I get a coupon, I will share it with you. I don't want you all to buy some costly courses. Okay. Okay. Perfect. Now let's continue. What are the advantages we have discussed about Neo4j? But now it's time that we understand about Neo4j property graph data model. Okay. Now the next topic that we are specifically going to discuss about is Neo4j property graph data model. Neo4j property graph data model. Okay. So here in Neo4j specifically, in Neo4j graph database. Okay. Here you have something called as property graph model. Okay. So in Neo4j graph database, you have something called as property graph model. And here you specifically store and manage data. You store and manage data. Okay. Now this property graph model, whenever you try to create any kind of nodes, right? Here with respect to this particular data, you have nodes, you have relationship, and you have properties. Okay. Now, this relationships, I'll talk each and everything. What are these properties? What are these relationship? What are these nodes? Okay. So this relationships, it can be unidirectional. It can also be bidirectional. Okay. And properties basically means this will be denoted in terms of key value pairs. Key value pairs. Let's say I'm creating a node about Rohit Sharma. Rohit Sharma, name is Rohit Sharma. Okay. I can create one key like name colon Rohit Sharma. I can say date of birth, right? I can say date of birth is nothing but 1980s something, right? Labels basically means the name of the node. Okay. So labels is what? It is nothing but names of the node. Name of the nodes. We'll discuss about it as we go ahead. Okay. So here, you'll be able to see most of the graph database that we will specifically create, which we are going to start in some time. Here we are going to have node 1. Let's say here we have node 2. Now, since I'm writing node 1 and node 2, that basically means the label of this node is node 1. The label of this node is node 2. Okay. Let's say node 1 is the parent of node 2. So this parent is what? Is a relationship, right? We basically say this as, in this kind of relationship, we say this as start node. This is my start node. This is my end node. This is my end node. Okay. Or we also say this as start node, or we also say this as from node, and we say this as to node. Okay. It can be mentioned anything as such. Okay. So let's continue, everyone. Let's start with the practical now. Yeah. So has everybody instance got created? We'll go ahead and start with our practice now. Okay. So how excited are you? Did you have the knowledge of all these things before? Okay. I have a basic idea how I created a knowledge graph from some small text using Langchain. I'm curious to know how we can convert a 200 pages file. It is easy. 200-page financial PDF, read all the text, convert that into chunks. I will show you. I'll show you as an example. I will not do 200, but I will do a smaller one because I'm using open source LLMs, okay, not paid LLMs, okay? Okay. Now, first of all, everybody has clicked this. Now, go ahead and everybody has downloaded the password file, right? So this is the passwords, right? Username, password, URI, and all, right? Instance ID, instance name, right? Everybody has done that, right? Perfect. Now, just go ahead and click on open. So once you click on open, so one paid session if distributed fine-tuning LLM with multi-purpose. See, Manorama, I can take paid session. Let me just try first of all with free one, okay? And then we will try to see, okay? So guys, once you go over here, do you see this connection URL and then you have this database user, right? So I will just go ahead and open my notepad file. So just go ahead and open your notepad file. So you know your URI is nothing but it is this. So I will copy this entire URI over here. Okay, I will copy this entire URI. So it starts from S colon colon. So I will just copy this from here. Oops, just a second. So I will copy this from here to here. So here we have this. Okay, I'll click on connect. So here, once I click on connect, you can see that it has got connected. So is everybody able to connect this? Yeah. It's a very simple way. Yeah. It got connected, right? No. See, click on this. Click on open. Okay. Because I have already connected it right now. See, I'll click on open. It will ask you this connection URL. Is it asking you connection URL? Tell the login details. Login details, it will be with you, no? This notepad have got downloaded, right? This text file, TXT file. Everybody is able to do this, right? Jayesh, if you join through mobile, then it is better you drop down. Okay, through mobile, how you'll connect to? Don't. I'm taking this much effort to teach you all. You are joining by mobile. थोड़ा तो इज्जत करो यार, है? Okay, see over here. So this is the URL. Take this entire URL and paste it over here. Okay, paste it over here and click on connect. Now I think you are able to connect it. Okay. Perfect. So see over here, try the Copilot also is a option is available. Copilot, generative AI assistance. I'm telling you, this Copilot or LLM models, these are also very good in generating cipher query language. Okay. As I opened, it did not ask me credential. Is it okay? Yes, it is fine. If it is directly opening, then it is fine. No worries. Okay. So till here, everybody is able to get it done. Please give me a thumbs up. Right? Yeah. Perfect. Great, 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 great. No, I'm lagging. Please give me some time, please, Krish. Okay, take some time. No worries. It's getting created. Okay, it's getting created. Okay, we do not even create right now. I showed step to create. Okay, no worries. Take your time. Take your time. And then talk. Let's talk something else then. Instance is being created. Let the instance get created. Sir, instead of LLM, can we use NER models? See, why you want to use NER models? LLMs are far more better than NER models, right? Why do you want to use that? Okay, for the people who do not know how to start with Neo4j, so go to Neo4j or RDB. Okay, go ahead and log in. Click on Start Free. So this is the dashboard you'll get. For a free account, you'll be able to create at least one instance, and this instance will automatically get deleted in 1 month. Okay, every month it gets deleted. So now I will just go ahead and click on New Instance. So in New Instance, you'll be having an option of free. Take free and click on Strive for free. That's it. Yeah. If I want to set up a location workstation, want to host, yeah, to host Llama 370 billion, you definitely require a huge GPU, right? For the inferencing purpose. Don't do that instead of wasting time. Okay. Use Grok. Grok API is there, completely free. Okay. So everybody's created it. Yeah. Done. Yeah, you will get the recording. I will share you the recording. I told you, no, I'll upload this entire video in YouTube. Okay. Don't worry. So everybody's created, right? Started, right? Yeah. Everything. Notes also I will share. Everything I will share. Don't worry. Okay. Perfect. Now let's go ahead. Let's go ahead and start working on this Neo4j. Okay. And let's first of all create a node with label. In order to create a node with label, we will be using a create command. Okay. See everyone, we are using a create command. Create command. Okay. Create command. And in order to give my node name, let's say I want to probably give some kind of name over here. Let's say I will go ahead and write Krish. Okay. And my label will be specifically person. Let's say I'm going to define like this. Okay. Krish person. Okay. Krish colon person. Now, when I say person, it is a person is a label of that node. Okay. Whatever node I'm actually creating. Now, if I want to give key value pairs, properties, so which we discussed right over here, we said that there are three main information. One is nodes, relationship, properties. First of all, we'll learn how to create nodes. Then we'll go and see with respect to relationship. Then we'll go and see with respect to properties. But here, while creating nodes, I can also go ahead and create properties. Properties will be nothing but key value pairs. So if I'm creating a person named Krish, I can give this entire information in the form of key value pairs. So in order to give the values in key value pairs, I will have name, colon, okay, Krish Nayak. Okay, so this is my name. And let's say here, I will give my second key name. That is nothing but born. Okay, sorry, this should not be in quotes. Born, colon, let's say I was born in 1989. Very simple, everyone. Create is the keyword that is specifically used, right? Like how you create table, how you create this. In order to create a node, we have to use this create. And when I wrote Krish, and this person is a label, right? Column name is name and value is Krish. Yes, the value is Krish Nayak and born is 1989. These are my attributes. You can probably consider this as attributes. Name and born. Okay. Name and born are my attributes. Attributes. In table, we have column names, right? Similarly, here we have attributes. Okay. Property keys and values. Okay. So once I execute it, see the magic on the left-hand side. Can have only one label? No, we can define any number of labels. I will talk about it. Don't worry. So if I go ahead and execute it, do you see person has got created? Now see, what was Krish over here? We'll try to see. It has said created one node, two properties and added one label. Now tell me what was the label? What was the label? Execute, see, on the right hand side, you'll be seeing this run button, right? Just run it, okay? So label, if I just go ahead and click on person, see, inside this person, if I go, okay, this person has born, name as your property keys, right? And Krishnak is basically been getting displayed. So what is Krishnak over here? Name. Yes? Do you see this information? So in short, when I executed the query, what was the query that I executed before? Create Krish. Krish is a node of label person, and the key value pairs were name and date of birth. Do you get it now, everyone? Yes. Krish is a person label. Okay, Krish is an entity like me. The label is person. Like I am a kind of person, you can consider, say. The name is equal to Krish, which is my key value pair, and born is 1989. Clear? Now see this amazing thing. Property keys, when I click on property keys, born in 1989. Name over here, Krishnaik. Okay. Now see, automatically this query is getting generated, right? Once I click born, name and all. If I click on person, see, match n is equal to person, n colon person, return n limit to. Krishnaik is basically getting displayed. Isn't it amazing? I did not have to write any query. And that is what I said about Neo4j. This is so amazing that automatically it will generate the queries also. Okay. Let's create some actors. Okay. By actors, you'll be able to understand much more better. Okay. Let's create Robert. Robert Downey Jr. everybody knows, right? I hope everybody knows, right? So Robert is also a person. Okay. Robert is also a person. Just a second. I'll use the same way of how I've used over here. Create Robert person. Okay. Now inside this person, what we really need to give? My key value pairs, and then I will close this. Okay. So what is the name of Robert? Robert Downey Jr. Okay. I hope everybody's seen Iron Man. I know you all are a big fan of Iron Man. Let's say this person was born. I don't know the exact date of birth of this person, but I'll just go ahead and write 1970s. Okay. So what we are doing over here? We are creating another person. The node is nothing but Robert. Okay. With this particular information and this. This is my label. Okay. This is the person. Like Krish, the label is person. So I'm creating another label, another person, another entity in another node in this label, that is person. Okay. So once I execute it, so now if I go ahead and click on person, do you see two people? Krish and Robert Downey Jr. Yeah. Do you see this? Now if I click on Robert Downey, I'm able to get this information. Yeah. Clear, everyone? Clear? Everybody is able to do this? Very much simple. Okay. Please show the query. Create Robert colon person. Person is my label. It's just like, you can just consider like this, right? If I consider person as a label, I can create any number of person inside that, right? So person is a generic label. Inside that, I can create Robert, I can create Krish, I can create Bhavish, I can create Kiran with my own key value pairs. Okay, great. Should I continue now? Don't worry, I will give you all these queries also. Okay, I can import all these queries. And then I will try to give it to you. I think there is an option called as import. Okay. Query. I think there is a way to import this. Disconnect. I'll see how to import all these things. Okay. We'll just have a look. Oh yeah. So here person itself should be enough, na sir. Why we are giving name again in start? This is not name. This is my node name. Robert is my node name. Node name is mentioned by a label. Okay, perfect. So let's go with the third one now. Let's create one more person. Um, do you know any famous actor now? Do you know any famous actor? Have you heard about Keanu Reeves? Yeah. Prabhas, Hugh Jackman, this, huh? Everybody's a big fan of this. But this is the most amazing guy that I have ever seen. His acting is quite amazing, down to earth person. Okay. So this person was from Matrix movie. Okay. So let's go ahead and execute this. I've created my third node, but the label is person. See, the reason I'm writing this specific information, this is just node. Okay. I'm trying to say that all the person information that I'm giving should be attached to one single label. Okay. So here you have this information. Now you see property key values are still increasing. Okay. Relationship, style, visualization, everything. Now if I go ahead and execute this, do you see three people are here? Keanu, Keanu Reeves, Robert Downey, and Krish Nayak. Okay. Perfect. Now it's time to create the most important thing is relationship. Okay. How to probably go ahead and create this relationship. Now, Robert Downey Jr. has worked in which movie? Avengers, it can be Iron Man, right? So, first of all, should we go ahead and create a movie label also, right? So, let's go ahead and create this. So, I'll go ahead and write create. Okay. Let's say the first movie that I create is Matrix, which is of a type movie. Okay. Of a type movie. And here I will be having my title. Title is nothing but The Matrix. And when did it got released? Anybody knows this? Released on, I think it is 1999. Okay, just check. Okay. Or whatever year you want to put. Okay. Now see, once I execute this, do you see movies created? Created one node, two properties, added one label. Okay. Then I will go ahead and create another movie. Let's say the movie name is Iron Man. So I'll say Iron Man. Okay. Title is nothing but the Iron Man. Okay. When it got released, I think in 2010. Okay. Just check. Okay. I'm just writing some 2008. Okay. I was very much near. No worries. So once I go ahead and click this, so here you can see one more node has been created. Now I'll click on movie. So here you have this Iron Man and the Matrix. Now, who has acted in Iron Man? Who has acted in Iron Man? Robert Downey Jr. So I will go ahead and match. Let's match. Now see, this is where I will show you how you can go ahead and assign relationship. Now you tell me which person has acted in the movie Iron Man. Which person has acted in the movie Iron Man? So here, if I go ahead and execute this, I know Robert Downey Jr. has acted, right? Now, with respect to Robert Downey Jr., what I will do is that if you remember, what node we have actually created for Robert Downey Jr.? Robert, right? This one. So I will go and copy this. We will match this particular record. So here I'm going to just go ahead and write match Robert. Okay. Match Robert. And Robert was a person type, right? Label is person, right? And here we will go ahead and write name colon. What was the name for Robert Downey Jr.? If you remember, I will just go ahead and write. I'll copy this. Oi, 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 oi. Okay. Name Robert Downey Jr. Okay. So first of all, we are matching this information. Okay. Okay. Name colon Robert Downey Jr. Is it fine? Match Robert person name. Query cannot conclude with match, must return a return clause. So we need to also go ahead and write a return clause. So once we will go ahead and do this match, I also have to do one more match. Okay. Match with, let's say, the movie Iron Man. Okay. So what was the movie with respect to Iron Man? What we really need to match over here? Tell me. So the movie is over here, Iron Man. Iron Man is the title. So here I will just go ahead and write. What I need to write? Come on, tell me, guys. Tell me. Iron Man, right? I think this is the same name that I've used earlier, right? See, Iron Man, yeah, colon movie, right? So here I will go ahead and write colon movie, yeah. And here also I will go ahead and write my name is equal to, or it was title or name? It was title, right? I think it was title only. If I go ahead and see, title, right? Title, then I will just go ahead and copy this Iron Man. I hope you are able to understand. Yes or no? Everybody. Yeah. So first of all, we'll match this two information. I have this information and I have this information because I want to make sure Robert Downey Jr. is having a relationship with this particular title called as Iron Man, movie title Iron Man. Now, oops. Just a second. Okay. Still, I need to write some queries. Now, what I will do over here, I will go ahead and write my create command. Now, we will go ahead and create a relationship. Okay. So, in order to create a relationship, I will go ahead and say, hey, use this Robert. Okay. Use this Robert and make a relationship. Make a relationship. Robert has acted in this movie. Okay. Acted in this movie. So, I will just go ahead and write colon. Okay. And I will write acted in. Acted underscore in. Okay. Acted underscore in. And when I'm saying that it has acted in this movie, okay, acted in this particular movie, then what I have to really do, I will just go ahead and give this with this particular relationship on what? On the Iron Man itself. So here I will go ahead and write Iron Man. That's it. Let's see whether I'll get an error. So here I'm getting an error. Let's see. Create this acted in metrics. I'm getting some error. Okay. Let's see. First of all, Robert, person name, create Robert, acted in. Let's see my notes, guys. Just a second. Just give me a second. Quickly, I will just try to have a look onto my notes. This I had just executed it a while back. I don't know why this is giving an error. Same, I'm also very new to this. So some kind of syntax issues will be there, but it's okay. We can fix this. Check Downey spelling. I think Downey is fine because I copied and pasted it from there. Use ChatGPT. It's okay. Sometimes we don't need to use ChatGPT. Just by things, you will be able to get it. Okay. One issue that I did. I have to put an arrow symbol over here like this. Now, do you see this? That has, I did not put this arrow symbol. See, I told you, right? Unidirectional or bidirectional. And this is unidirectional, right? So Robert has acted in Iron Man. So I missed this arrow symbol. Okay, that was the syntax issue. Now see, do you see this relationship that is getting created? So let me copy and paste this query for everyone. Okay. So here, if I click on acted in, now do you see something amazing is seen over here? Robert Downey Jr. has acted in Iron Man. Okay, please make sure that you match all the words with respect to the things that you have developed. Okay, clear everybody? Yeah. So this is the graph that we are able to get. Okay. And the best thing about when we work this with Langchain, it's okay if you are not able to copy it. Can you paste other commands? You're not able to copy it. I'm able to copy it. Okay. I think you should be able to copy it. Unable to copy. No worries. Just go ahead and write this then. Match Robert colon person. Name Robert. Okay. Downey Jr. Iron Man. So here you have this Iron Man movie title. So what this two query is doing? This is basically matching the information. One node I have this side, one node I have this side. And now the last one I have basically created a relationship. Okay. So how can we get the node name, sir? See, if you just go ahead and execute this, don't you think you'll get the node name? Yeah. Return, return, whatever the result is, right? So here you'll be able to see, right? Whenever we try to probably specifically match something, right? You'll be able to get this. Yeah. I will show you. Don't worry. But I hope everybody's got this understanding. Yeah. We have just started it right now. More things will be discussed as we go ahead. I'm getting error. What error are you getting? Okay, let's do one more thing. Let's do one more time. Okay. Let's do one more time. First of all, we'll try to create this. Okay. So how many persons are over here? So do you see over here Keanu Reeves? This person has acted in which movie? Matrix, right? So if I go ahead and click on movie, do I see Matrix over here? The Matrix, right? Now let's go ahead and link that person to this movie Matrix. Okay. So first of all, what I will do, I will write match. Okay. I will go ahead and match which value, first of all, Keanu, and this was a person type. Yes? Yes or no? Everybody see this. Focus over here. Match person type. Okay. Then I will go ahead and write name colon. Right. So when we go ahead and write name colon, what is the person name over here? The person name is this one, right? The person name is this one, Keanu Reeves. So I will go ahead and copy and paste it over here. Yes. So this match is done, everyone. Now to which movie title I have to probably match this? Which movie title I have to match it? Come on, tell me. I will go ahead and write Matrix, which is my colon movie. Okay. And then, oops, Matrix colon movie. And then my title will be my key value pairs, right? So I'll go ahead and write title colon. What is the movie name over here? If I go ahead and click on the Matrix, it is nothing but the Matrix. So I will copy this entirely. I'll paste it over here. Yeah. So once this match is done, what is the next step? We go ahead and create a relationship. So how do we create a relationship? Create whatever node name is there, Kyono. Here we will just go use a single unidirectional relationship. And here I will say, hey, go ahead and write acted in. Okay. Acted in, then this will be unidirectional. It is acted in which movie? In the Matrix movie. Okay. So here you can see, I will just go ahead and execute this now. Has this got executed? Created one relationship. Now, if I click on acted in, do you see this information? Keanu Reeves has acted in the movie The Matrix. Simple. Yeah. Guys, don't paste the query. Don't just paste the query. Please write down the query. You'll see what problems you'll be facing. Okay. I can just go ahead and give you this particular query. No worries. Right. So here you have Kyone person's name is equal to Kyone Rivers. You're doing this match with the movie match, right? You get this two information and then you go ahead and create anything as such. Is it difficult to understand or should I start more from basics so that you'll be able to understand quickly? More from basics? Yes, we are now going to link this to Langchain. Yeah. You're able to understand it, right? Understandable, right? Okay. Let's start some more things, some more basics. I don't know why you are facing, but understand as a generative AI engineer, you will not be perfect in cipher query language. It's more about understanding things, how we are able to link one thing to the other thing, right? That is what we are basically going to do. Yeah, syntax seems to be a bit confusing. I know that if you're seeing it for the first time, there are some queries like match, there is also for each loop and all. But don't worry, our main aim is to learn along with LangChain, not to become a perfection in cipher query language. Okay. Google will always be there to help you out. Okay. No changes, no record. It for some reason not generating relationship. In relationship, name should have some standard like acted in. Yes, that is the relationship name. Okay. That is the relationship name. Let's do one thing. Okay. Everybody open Google Colab. We'll start working on Langchain. Okay. Everybody open Google Colab. What is the use in the real time projects? I will talk about it. Okay. So let's go ahead and open your new notebook. Okay. We will try to do the query. How to query this DB? I will show you here with the help of Python programming language now. Okay. So till here, again, you can go ahead and try out different things. But again, we will just try to probably go ahead with this. Okay. So I will just go ahead and select one of the runtime environment. Okay. So everybody please open the Google Colab and just give me a confirmation if you have opened it. Okay. Just give me a confirmation if you have opened it. Open ready? Perfect. Connect. Yeah, just do that. Okay. I will also share you this entire link. Okay. I'll share you this entire link so that you can write the code along with me. Okay. Just let me know once you get the link. Do you get the link? Now, what we'll do, we will insert some of the records in this GraphDB with the help of Python programming language along with Langchain, and then we'll try to query it. Okay. And we'll be doing that entire thing over here. What are the few things which GraphDB can and RDBMS cannot? Right? See, RDBMS is much more of a relational database management system. This is not relational completely. And there are inside operations with respect to constraints, with respect to some kind of queries, most of the thing matches, but there are a lot of differences with respect to the syntax. But as a developer, we should definitely know how to do it with Langchain if you are specifically interested in generative AI engineering. Okay. Quickly, let's start, everyone. Shall we go ahead? So first of all, we will go ahead and install all these things. We'll be requiring Langchain. We'll be requiring Langchain community. We'll be requiring Langchain OpenAI. Instead of Langchain OpenAI, let's go ahead and write Langchain Grok. We will use this Langchain underscore Grok. Okay. Why I'm using this, I will tell you because we'll be able to use the open source LLM models. So let's execute this. So once this gets executed, just let me know. Okay. Pip install, upgrade, Quiet Langchain, Langchain community, Langchain Grok, and Neo4j. We are going to use Neo4j over here. Done? Everybody? Just give me a quick yes once you have completed. Okay. Done? Okay. Now, in my next field, I will go ahead and create my three fields. One is Neo4j URI, Neo4j username, and Neo4j password. Where you get this entire information? From your notepad. Do you remember this? Do you remember this information? So I will copy this entire information because in order to connect to the GraphDB, I require this information. Okay. So here you have this. Here you have this. Then username is Neo4j. I will copy this. I'll paste it over here. Okay. And password is nothing but this information. So you need to install, first of all, Langchain, Langchain community, Langchain Grok, and Neo4j. Okay. And these are my GraphDB information. GraphDB configuration. Guys, are you able to see my notebook, the link that I have actually given, right? You can copy it from there, no, Manish? So if I've given you the link, I've shared it with everyone. You can just go ahead and copy the links. If this is the code, you just go ahead and copy it. Okay. Don't use my graph database. At least put your graph database information. Okay. So let's go ahead and execute this. Everybody has this their own personal information, right? Don't use mine. Please don't use mine. Otherwise, I will not be able to query much. Just a second. Vinay Kumar says how to get the notepad. Vinay Kumar, initially once you created the instance, right? You got an option to download, right? From here. Yeah. Link is not copied or restricted from chat window. Are you not able to access this Google Colab link? Just click on that link, no, brother. Just click on that link. Hmm? Yeah, just click on that link. Come on. Hmm? Pip install this. Can access it. Not an issue. Yeah, just click on that link. It'll open it, right? I'm writing my code. You just need to go ahead and replace this URI, username and password. Copying, you cannot do it, but you can click that link. Okay, please click that link. Okay. So everybody has their own configuration, GraphDB configuration. Yes. Everybody, just a quick yes. If you have your GraphDB configuration, perfect. Yeah. Great. Now what we'll do, we will go ahead and execute this. Okay. Let me go ahead and make a new cell. Now the next thing what I will do is that I will go ahead and add import OS, os.environment. I will set up all these environments. The first environment is nothing but my Neo4j URI. And this environment will be set up with this particular value, right? So here I'm going to write my Neo4j username with this username, password and all. See, there is one way is that all this information, you should not keep it openly, right? Instead, what you can do, you can also put it in your private key if you like. Okay. But it is up to you. Please try to use in that way. Okay. So here I've just copied it over here so that you can use it. Okay. Perfect. So this is my environment that I've actually set it up. Now in the next code, I will go ahead and write from Langchain underscore community dot graphs. I'm going to just import Neo4j graph. So let me quickly go ahead and write graph is equal to Neo4j graph. Okay. And here you can see, right? URL, I will set one value. Username, I will set one value. Password, I will set one value, right? This three information. So I know my URI is nothing but Neo4j URI. Password is nothing but, username is nothing but Neo4j username. And password is nothing but Neo4j password. Okay. So once I execute this, you will be able to see that I will be getting the output. Yeah. So has successfully got executed for everyone. So this is my graph. So this basically means it has now connected to my graph database. It has connected to my graph database. Clear? Clear, everyone? Yeah. Yes, it's connected. Perfect. So for this, we use something called as Langchain underscore community.graphs, import Neo4j graph. And Neo4j graph actually helps you to connect to your Neo4j database. Okay. This is your GraphDB configuration. Don't copy mine. Copy yours. Hmm? Copy yours, everyone. Okay. Your information you have, right? GraphDB. Hmm? Perfect. So till here, everybody is able to understand, right? Perfect. Now, let's do one thing. Since we are going to use our open source LLM model, have you used Grok at any point of time? Grok.com. Yeah. So go to grok.com. Go to this particular website, grok.com. Grok.com actually provides you open source LLM models. See, recently you also have Llama 3.1, Gamma 2. It provides you API to access all this open source model. Okay. Sumit Dar, I have given you the link, na brother. Hmm? Take this link, click this link. Okay. Click this link and whatever code I'm writing, just see to that. Okay. Is Grok API free? Yes. For some number of requests, Grok API is free. Okay. Okay. So everybody go ahead and log in into the Grok API. Grok, and this Grok actually provides you open source LLM model. Any open source LLM model you can specifically use, like Gamma 2, Gamma 7 billion, Llama 3.1, 70 billion versatile. This is the new model that has come recently. Llama 3.1, 8 billion instant. Then you have Llama 3, 7 billion, 8192. Then you have Llama 3, 8 billion, 8192. All these particular models are specifically there. Okay. Is Llama is completely free? Yes, it is free. Okay. Now, once you log in, have you logged in, everyone? Sir, why are we using this? Just to show you the power of LLM with GraphDB. Okay. I will talk about the use case that I'm actually going to solve. Okay. Yeah, Llama API is free right now for this. Okay. Okay. Now, if you go over here, click on Grok Cloud. Okay. Once you click on Grok Cloud, do you see this particular console? Now, in this console, go to the API keys. Okay. Now, here in the API keys, you can go ahead and create your own API key. Right? You can just go ahead and click on create and create your own API key. Yeah. Because we will be using this API key to access any of that specific model. Everybody copied it? Yeah. So go ahead and create it, everybody. Keshav Gar, please focus on this session right now. Create an API key and copy it. Copy it, keep it ready. And then we are going to use that particular API key over here. So let's say I have my API key. I will go ahead and write Grok API key is equal to, this is my API key. Okay. Don't expose it to everyone and don't use mine, use yours. Okay. So where you get that option in Grok, click on Grok Cloud. Okay. Grok Cloud. Then here you will be able to see this Grok Cloud over here. And inside this Grok Cloud, you have something called as API keys. And inside this, you can go ahead and create your API key. Clear? Manish Raul? what error you are getting, just click on create API key, write the API key name and click on submit, and then copy that API key and keep it ready. Okay. And then what you will need to do, create a variable called as grok underscore API underscore key and just write it in there. Okay. Which LLM model have you chosen in this grok? We will select any of the LLM model. Let's say we'll go ahead and take Gamma 2. We'll take this model, Gamma 2 9 billion, right? This is the recent model from Google Gamma. Okay. Clear, everyone? Shall we go to the next step now? Okay. So, as you all know, we have already installed Langchain underscore grok. Now, quickly, let's go ahead and import Langchain. So here I'm going to write from Langchain underscore grok, import chat grok. Okay. So chat grok actually helps you to connect with your grok models. So whatever open source models are available in the grok API. Okay. Now I will go ahead and create my LLM variable. And this will be nothing but this will be chat grok. And inside this, I will be using my grok underscore API underscore key is equal to grok API key. Grok API key. And what is the model that I will be using? So if I go ahead and write model underscore name, this is my second parameter. The model underscore name, I have to probably go over here and select any of these models. Let's say I'm going to use Gamma 2 9B IT. Okay. So please make sure that you remember this name, right? The spelling should be exactly right. Gamma 2 9B IT, right? So here I will just go ahead and copy this Gamma 2 9 billion IT and I'll paste it over here. Okay. And now let me just go ahead and create my LLM. So once this gets executed, here you'll be able to see. Are you able to see this? Yeah. So here you'll be able to access your Gamma model. Okay. I don't know why the name is IT over here, but they have written the model name is something like this itself. Okay. So here you can see Gamma 2 9B IT. And now we are able to access this particular model using ChatGrok library. Perfect. Happy? We usually have PT, that's why. Hmm. This is for IT people. Perfect. So Olama is free or partially? It is free, but it depends on your local machine. Grok, it provides you amazing inferencing and it is for free, right? Free only for some request. Now let's go ahead and do one thing. Let's take one specific small document. Okay, I'll take some text. So I'll write, hey, from Langchain underscore core dot documents, import documents. Okay. So I have this documents, Langchain underscore core documents. I will take some text. Let's take this text. I will just write triple quotes, a multi-line text. And let's say for this text, I will go ahead and give some information. And this is related to Elon Musk. Okay. So do you see this entire information? So I've taken this particular text. I've just copied from the Wikipedia. Okay. And you can take any text and then we'll try to see how this is basically getting converted. So this is my text over here. Okay. Perfect. Perfect. Okay. Is Grok completely free? Yes. For some number of requests, it is free. I think you can use it. Okay. So this is my text. Now what I'll do, I'll take this entire text and then we'll try to convert this into documents and then we'll insert into the GraphDB in the form of graph knowledge. Okay. Now, if I have this text, in order to convert this into documents, what I have to do, I'll just go ahead and write documents is equal to And here I'm going to specifically use documents. Okay. And I'll write page underscore content is equal to text. Once I do this, this entire text will basically get converted into documents. So let's go ahead and execute this. Indentation error. The reason is very simple. Okay. Now, if I go ahead and just print all my documents, here you'll be able to see this. See, this is basically converted into a document itself, right? Initially, we'll have a document and then we will probably convert that into chunks and all. Do you think we need to convert this text into chunks? This is a very small text, right? Yeah. So do you think that I should convert this into chunks? No, no need, right? If I really want to convert it, I can use recursive character text splitter and I can probably convert that into chunks. But this is a small text, so I'll not go with this. I think this much context will be handled by the LLM model. Okay. Now what we'll do by using the LLM, we'll try to convert this into uh, the graph database itself. We'll try to convert this into a graph document. Okay. So here you will be able to see that I will go ahead and write from Langchain underscore experimental dot graph underscore transformers. Now see, there is one library that we need to install, which is called as experimental. So I'll go ahead and write pip install upgrade Langchain experimental. So let's go ahead and execute this. So this will get executed because I need to have Langchain underscore experimental. Okay. So I will go ahead and write from Langchain underscore experimental dot graph underscore transformers. We are going to import something called as LLM graph transformer. Okay. LLM graph transformer. And here I'm going to just go ahead and create my LLM underscore transformer. What this will be doing is that whatever documents we specifically give, it will convert into a graph document. Graph document basically means it will take this text and it'll say, hey, which is the nodes? What is the relationship that can probably come up? Okay. So here I will just go ahead and write LLM transformer. LLM is equal to LLM. Okay. Clear, everybody? Yeah. So once I execute this, you'll be able to see that this has got successfully executed. Okay. So if I have multiple chunks, how do I create the graph? It will be possible. I'll show you. Okay. Now I will use this same LLM transformer dot convert underscore to graph documents. Okay. So once I use this function of graph documents, and there I'm just going to give my documents, right? So we'll just give this specific documents that we have created. Okay. Now I'm just right now converting this into graph documents. That's it. So I'll go ahead and execute this. Now see the magic, what will happen now once I probably display all your graph documents. Okay. So this is taking some amount of time. That basically means it is taking all the text and it is converting that into nodes, right? And again, based on the text and all, it will take some amount of time over here also. Let's wait for some time. So here we are basically using graph underscore transformers. This is responsible in converting your text into. So I'm getting an error message saying that internal server error. I think our LLM is specifically not working over here. Let's see. Just a second. It's worked for you. Let's execute it once again. Sometime it will work, sometime it will not work. Let's see. For you, how many people it is working and how many people it is not working? It worked for me too. Yeah, for some people it will work. For some people, I think it will be giving some error. Okay, it worked for me this time. I think we are we are executing the same thing for everyone is executing the same thing, right? So it is working over here. So here you can see now that means something is using your credential. Yeah, someone was using my credential. Very naughty guy. I don't know why they want to use my credential. They don't use their own credential. For the people who are not working, they just using my credential. Lazy people. Hmm? Okay. Clear, everybody? So here, okay, right now it's okay. So here, everybody, you can see over here. Sayed Mohammed, just execute it once more. Okay. So do you see over here, guys? Nodes, ID, type, right? Type. You are getting everything over here. Yes or no? Are you getting everything? All the information? Right? Now let's see the first node. So I will just go ahead and write graph underscore documents 0 dot nodes. So if I just want to go ahead and see the nodes, so these are all my nodes that has been created. Yeah, these are all my nodes that has been created. What all nodes has been created? See, if I just give the text, Elon Reeve Musk, the type is person. My type is person. Do you see? Similarly, we created that, right? While creating our nodes in the GraphDB. Yeah. Then you have this Pretoria. Then you have University of Pretoria. This is location. This is educational institution. This is Canada location. Queen's University, educational institution. University of Pennsylvania, educational institution. See the types. Now just imagine if you have this information, don't you think you can create the nodes? Yes or no? Don't you think if you have this information, you can go ahead and create the nodes? Now you just, if you go to your Neo4j DB, what we did, we also created the nodes like this only, right? Kiona person. So similarly, if a location is there, Canada, this will be location, right? The same information is available over here, right? Type. The second label that you see is basically your type itself. Yeah. Yes, I will also show you how to create relationships directly. Okay. So now this also created a relationship. Now we are checking out the nodes. See, from this we checked out all the nodes. Now let's see with respect to relationship also. Can we see the relationship? Now in order to check the relationship, I'll go ahead and write graph documents of 0 dot relationships. So if I go ahead and execute it, you'll be able to see the relationship. See, Elon Musk, type person, target node, Maya, type person, type parent. See, parent is there, right? It's okay. See, same name, we can also give it with multiple types, multiple labels. See over here, Elon Musk, Elon Musk, type person, type parent. Elon Musk, Pretoria, type location, born in. He was born in Pretoria. So it is basically given, right? Then here you have Elon Musk. He studied from University of Pretoria, type educational institution, type attended. See, two labels has been there. One, this type and this type. And this is my another relationship called as attended. So let's do one thing. Let's create a RAG application. Okay. Now this time the RAG application that we are specifically going to create will be of a different type. Okay. Uh, we'll have some kind of data set in our CSV file. Let's say that in our example, we are going to have this data set. Let me just show you this data set. Ramesh, I will show you in diagram. Don't worry. From that much time, he's asking only diagram. Okay. What you'll do with the diagram, I'll show you in directly in GraphDB, no? Okay. So here, do you see this particular data set, guys? Movie ID, release, title, actors, directors, genres, IMDb ratings. Okay. So here you have values like movie ID, release date, title is Toy Story, actors, there may be multiple actors. So with respect to actors, you have this slash, slash, slash. Do you see this? Similarly, with respect to directors also, you have, with respect to genres also, you have this slash, 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 right? Multiple genres it may belong to. So I hope everybody is able to see this data set. Yeah. So I will just share you. Please go ahead and click the link. Okay. So this particular data set we'll be using. Now, the first thing what we are going to do is that we're going to read this entire data set. We are going to insert all this data set into our GraphDB. Okay. Now, in order to insert this particular data set, now Cypher query language also provides you option for loading this entire data set itself. And we need to generate the queries for this. Okay. So shall we go ahead and see that how we can actually do this? Yeah. Yes. Okay. Let's go ahead. So now, first thing first, let's load the data set of movie. Okay. Movie data set. So this basically becomes my movie underscore query. Now this movie underscore query, here we are just going to write triple quotes. Okay. And here we specifically need to write our Cypher query. Now for writing the Cypher query, how do we use this with respect to movie dataset? Okay, I'll be just querying this one. I will be writing this particular query. Okay, and I'll be pasting it over here because it is a big query. The reason it is big, you'll understand this, but just by seeing this query, you'll be able to understand. See, this is a function inside load CSV with headers, right? So if you go ahead in your Neo4j, if you go ahead and see load CSV, you see load CSV, there is a function called as like this, load CSV. And this load CSV will load any dataset from a CSV file. Okay. So over here, if you see over here, let's focus on this. Then I've already shared the link with this of your Google Colab link of the Google Colab notebook with you. So you'll be able to see this query. So here you can see load CSV with headers from. This is my CSV URL. Every row we will refer with this particular row variable. Okay. Now, when we say merge, merge basically means adding the records. If this record is already present, then it will not add. But if the record is not present, it will add. Okay. It will add. Okay. Yes, Ankit, you're absolutely right. We can also import data using the tool, right? Now see this, everyone. M, what is M over here? M is my node, right? Movie is my label name, right? ID colon row dot movie ID. See, since we are referring to this particular row, if I need to have one property ID, see, if I go ahead and open this, do you see movie ID is over there? One attribute is movie ID over here. So if I write row dot movie ID, don't you think we are referring to this particular movie ID? Yes or no? Just give me a quick yes. Yeah? Yes or no? Everyone. See over here. We are basically writing ID colon row dot movie ID. So ID is my first property key, right? Similarly, when we are merging this, we are setting another properties like m.released. M.released is my another property. Why released? Because my second property or second attribute is released, right? So here what we are doing, we are writing m.released and then we are converting this row.released to date. Yes or no? So this is basically typecasting to date. So in Cypher query language, you have this option. Then you are creating the next property called as m.title, where you are assigning row.title. Then you are writing m.idbm rating. Then you are converting this into float, to float. Okay, to float is the function that is used. And here we are using row.imdb rating. Clear, everyone? At least clear with this? Yes or no? Yes. Now see the next option. Why we are using for each? Have you do you know for each loop in Python? See, for directors, you know, there are multiple directors. Yes or no? If you see over here, with respect to directors, you'll be seeing somewhere you'll be getting this kind of slash, 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 slash. These are like multiple directors. In a movie, multiple directors can happen, right? And we have to probably split each and every director and we have to probably insert it. Jai Harish says, Krish, what is merge? What is merge doing? Merge is basically inserting the records. If that record is already present, it will not insert. But if it is not present, it will insert. Okay. So if the data is very huge, do we need to manually type this query? Yes, we have to do it for the first time. Yeah. Okay. Explain ID is equal to row. Where ID is equal to row I have written. id colon row dot movie id. Okay. id colon row dot movie id. Row is nothing but the row. It is referring to this particular CSV file. Okay. id colon row. If you write id colon row, whatever is attribute is present inside row, it will get inserted in this particular id itself. Okay. Clear? Everybody clear now? So even though you have a data frame, you need to convert in this query itself. First of all, get that entire data frame in this particular row variable, record by record. Then inside this row, you will be having this movie ID, released, title, IDMB rating. These are my attributes. Clear? Everybody? Yes or no? Come on, let's give me a quick yes if you're able to understand this. Perfect. Now, in the next statement, you see directors, there are multiple directors that are present in one row. So what we are doing, we are writing this for each loop and we are writing director in split row dot directors, right? How we are splitting it? By using this pipe symbol. Yeah. So once we split that, whatever values we are getting, we will go ahead and merge. Merge basically means again, we are inserting that records. This time we are inserting with a new label that is called as person. So here you can see person, name colon, team director. So name is nothing but your attribute. See this. Just by seeing it, you'll be able to understand whatever things we have discussed. Okay? Clear? Yes or no? So here what we are basically doing, we are directly reading, we are loading the CSV file and record by record, we are appending inside our query to insert it into the graph database. Tell me guys, is this clear? So we are writing P colon person, name is equal to trim or director. Yeah. Then what is the next statement that we are doing? Come on, tell me, what is the next statement that we are doing over here? Since we are inserting record by record, we are also adding the relationship. See, this particular person has directed this movie. This movie information is already present over here. So this way we are adding the relationship and this is also happening record by record. So when I am inserting the record, first of all, I will insert release date, title, IDMB rating. When I get the director field, I will go ahead and split it. And I will also make sure that I'll keep a relationship of directed to that specific movie. And that is what we are basically doing over here. Yes, this is a Neo4j query, Cypher query language. Then again in the next statement, for the actor also we need to do the same thing because actor will be present multiple times, right? Slash by that pipe symbol. Then again what we are doing, we are adding that particular actor in this person label. And here we are saying, hey, it has also acted in this particular movie. Just go ahead and create the relationship. So during the runtime, we are creating the relationship also. So what does this basically indicate, guys? This is the continuation. This is the continuation for this particular loop. Okay. In Python, we have indentation. Here we don't have indentation, right? It's just saying that we are inside this particular loop. It is just saying that we are inside this particular loop. Clear? Lokesh? Yes? It is saying that we are inside this for each loop. That's it. In Python, we have indentation. In this, we don't have. Now, similarly, over here also you can see that for genres, right? Row.genres, then again G.genres, and then why we are keeping this relationship with movie with genres? Because movie will be having some genres. Here we are adding some more relationship. Yeah. We can also create this query by LLM. Okay. We can also create this query by LLM. You just need to give the link and automatically LLM will give you the entire query. Okay. But first of all, let's go ahead and do this. Okay. So clear everyone with this query? I know it looks tough. I will definitely say it looks tough, but it is easy still. Okay. You just need to know the internet syntaxes, how things are working. Okay. So, but here we are not using any package function from Neo4j. Now, with respect to LLM, I will talk about it, how to do it. Okay. Okay. So everybody clear? So what we are doing over here, we are loading this particular data set from the CSV as row. We are merging movie ID, released, title, IDMB rating, right? And then with respect to this, we are splitting for each and every director. And And on the runtime also, we are creating the relationship with respect to director, person with movie, right? P is the node with respect to person. M is the node with respect to the movie, right? And then we are creating three relationship. One is directed, acted in, and in genre. You'll be seeing it, okay? Once I execute it. Let's execute this. So this is my movie query, okay? Now, I have actually created my graph, right? What is my graph? My graph is this one. Earlier we created. This is my Neo4j graph. Now see how simple it is just to insert all this particular records into the graph database. We will just go ahead and write graph dot query. And here, what I'm going to write? My movie query. It's just like executing your query. Movie underscore query. So once I execute this, it will take some time. It is running. Do you see something blank over here? That basically means it has got executed. Now let's go back to your Neo4j. Okay. Let's click on person. Do you see how many person nodes are there? 25. Do you see movie? 25. Do you see acted in? So if you go ahead and zoom in, you'll be able to see all the information. See? Othello, Anne Frank, Mary have actually worked in a movie, acted in a movie. Kenneth, or this particular person has acted in 3 movies, right? Mel Gibson has acted in this movie from that particular data set, entirely from that data set itself. समझ में आ रहा है एवरीवन? Yes or no? Come on. Beautiful, right? And how simple it was. So this is how my graph database looks like. I can zoom in, zoom out. This is more intuitive than SQL table. Yes. I cannot maximize. I don't know whether I'll be able to maximize this or not. Okay. Perfect. Here. So director relationship did not appear. Let me check why it did not appear. Let me just reload this. I don't know whether it has reloaded or not. See, I just reloaded it. Now it came, right? So directed. Oliver Stone directed Nixon and Natural. Just reload this. Yeah. Amazing. In genre. See? Wow, this looks good, right? See? Toy Story is also comedy. Sabrina is also comedy in genre. Grump is also in comedy. See? Beautiful. Nice, right? See, just I had a CSV file and we converted this into entire graph knowledge, right? Now you just go and write your cipher query language, you'll be able to get all the response, right? See, I just typed this query, match P in genre, return P, limit 25. So it is just saying that, hey, go ahead and see the relationship over here. If I go ahead and click this, it will give me more information about this. And just imagine, guys, the entire Google search engine is working behind in this way. And right now, this Neo4j, this is a complete open source database. Yes, for cloud and all charges you really need to give. But this entire is open source. Yes. Yeah, we can also download it. Let's see. Let's download as PNG. So this has got downloaded. Wow, this looks beautiful. Hmm? I am enjoying the session. What about you all? Huh? Instead of CSV, how can we do with PDF text? It's simple, no? Read that PDF, get the content, divide that into chunks, and convert that entirely into this. Send this, right? That is simple. Okay. Now let me do one thing. Let me just go ahead and show you and execute this. Graph.refresh schema, I'll show and we'll see the entire schema. Okay. So here you can see person, born integer, name string, movie. These are my key value pairs. Genre, these are my key value pairs. And these are the relationship it has created. Right? These are my relationship it has created. Now the question comes that how we can specifically use LLM model. That I did not talk about, right? How we can use as RAG Q&A. Now, if you really want to retrieve anything, you need to write an LLM query, right? Sorry, you need to write a cipher query language, right? And cipher query language is a pain in your everybody's mind, right? It's a pain, right? So let's do one thing. Let's create this cipher query with the help of LLM model. Okay. So now let's go ahead and write from Langchain dot chains. Import cipher query language, cipher QA chain. Okay. So here we are going to import graph cipher QA chain. Okay. And then we'll write chain is equal to cipher QA chain dot from underscore LLM. And inside this from underscore LLM, I have to give my graph assigned to this graph LLM with all my LLM that is created and verbose is equal to true. And just by creating this chain, now I can go ahead and ask any question that I want. Okay, so this is how you basically create a chain. And the Langchain, why Langchain is so amazing, guys? It has everything. It is trying to create something that it is compatible with each and every model, right? Compatible with each and every model. So now, once I created this particular chain, in this chain, I have written LLM, I've given graph, and then this automatically creates a cipher QA chain. Now, whenever I write a query, so first of all, what this graph cipher QA chain will do, based on that query, it will create a cipher query language. And then it will hit the database because that database information is present over here. Now, see the response, okay? Let's see, any movies are specifically there over here. I will take up any movie. Golden Eye. Okay. Let's see over here. So here, what I will do, I will write chain dot invoke. And here I'm just going to go ahead and write my query. Right. So query is equal to, and let's say I will go ahead and write who was the director of the movie Golden Eye. Okay. Do you think we'll get the response, everyone? So let's go ahead and see the response. See this? Wow. Answer is Martin Campbell. Did I write this query? I don't know how to write a query, man. This entire query is basically written by whom? The LLM model, right? So match M colon movie title, Golden Eye, directed P person, written P dot name. Okay. Let's go ahead and ask some other query. Who was the director? So here are there. Who was the actors of the movie Golden Eye? Himanshu, if it says mine returned, I don't know. Some problem is there. Why this is taking so much time? Hey, how many people are hitting my database here? Eh? Don't do that, please. It is taking so much of time. Everybody is using my database only. Eh? This is wrong. I want, I want to show you how to execute it, and you all are using my database itself. Hmm? There are many people who are using my database. I don't know whether my account will be stable or not after this. See, for you it is getting executed. Now it has got executed. Who was the actors? Pierce Brosnan, Famke, Jason, CN Ben, Isabella. All this information is there, right? So here you can see that this is the query that is basically coming, right? Let's say I'll go ahead and write who were the actors and directors of the movie Golden Eye. The actors were this and the directors were this. See, both the answer it is basically giving, right?